Alright, now that we have all the prerequisites completed, now we can start with the selection sort algorithm in this video, right? So there are a few things that I must say first before I begin with the algorithm. So we have this table here, and I here represents the position where we must place the correct element. For example, first we need to place the correct element at position 0, then we need to place the correct element at position 1, and then at position 2, and so on, right? So I represents the position at which we must place the correct element, and size denotes the length of the array ARR. So we have 7 elements in the array, therefore size has a value of 7. All right. Okay. So in the very beginning, in the very beginning, what we need to do is we need to place the correct element at position 0, right? So I would have the value of 0. Now, in which index range do we search for the smallest element? We would start searching for the smallest element from index 0 through index 6, right? So we start searching from the smallest element from index 0 to index 6. Now, upon searching, we see that 18 is our smallest element, right? And what is the index of the smallest element? That's 2. So we write 2 here. And the index, we swap the elements at index I and smallest index. The value of I is 0. Therefore, we swap these two elements. Just a second. This with this. All right. And one more thing that I must tell, that every time we search through the array, right? Every time we go through the array, this is known as a pass. All right. So upon swapping these, we will get another array. So let me copy this and let me paste it. Let me paste it here. So we're going to get another array where instead of 38, we're going to have 18, and instead of 18, we're going to have 38, right? And I'm going to circle the element that have been placed in the correct position. See, we are sorting the array in ascending order. Because we are sorting the array in ascending order, we are placing the smallest element at the first location. Next, we must place the correct element at position 1, right? So the value of I would increment to 1, and the index range to search for would now be 1 through 6. Now, why 1 through 6? You see, the correct element has already been placed in the 0th position, right? So we no longer need to search elements from 0 to 6, because we already know that the correct element has been placed at position 0. So we can start our search from the second element, thus from 1 to 6, right? Now, if we start searching in this location, we would find that the smallest element in the range 1 to 6 index is 22, isn't it? Because it's 22, the index is 5, and we must swap the elements at position 5 and 1, meaning this, let me write this properly, this would come here and this would come here. All right. So copy this thing, paste it. So upon swapping, 22, which is the color, 22 would come here and 41 would come here, and 22 has been placed in its correct position. All right. Same drill. We're going to increment the value of I, and the value of I is going to now be 2. And next, we are going to search for the smallest element in the index range 2 through 6. So from this to this, we see that from the index locations 2 to 6, the smallest element is 34. Therefore, we swap 34 with 38. So the index of the smallest element is 6, and we swap it with 2, I smallest index. Alright, so after swapping, we would have an array. We just duplicate this slide first. Alright, so after swapping, okay, I forgot to copy this. Alright, so after swapping, we would have 34 here instead of 38, and 38 will be placed in this location, right? And every time I place a correct element at its position, I'm going to circle it. All right. Now, the previous value of I was 2. So, the next position where we must place the correct element would be 3. Now, the index range that we must search to find the smallest element would be 3 to 6. Now, from 3 to 6, the smallest element that we can find is 38. So 38, the index of the smallest element is 6, and we must swap it with the element at the index position I, that's 3. So we swap the elements 38 to 50, and 50 would come here. All right, let's duplicate this, copy, paste. .38 would come here, and 50 would go here. All right, and because 38 has been placed in its correct position, I'm going to encircle it. All right, next we're going to place the correct element at position 4. So I would increment to 4, and the index range that we need to search now would be from 4 to 6. Same drill, mind you, only the I is keeping on incrementing. All right, so the smallest element in the index range 4 to 6 is 41. So 41 must be swapped with 68. Now after doing that, so the index of the smallest element is 5 and I is 4. Right, we swap these two elements. All right, so let's copy this, copy, paste, and get rid of the arrows now. Okay, so 41 would be placed here, and 68 would be placed here. Because 41 has been placed in its correct position, we'll encircle it. If you see, from position 0 through 4, the elements are arranged in ascending order. So the next position that we need to place the correct element is 5. So I would increment to 5, and we would need to search the index range 5 to 6. Now in the index range 5 to 6, we find that 50 is the smallest element, and its index is 6, and we must swap it with 5. So this is the swap that's going to take place. All right, let's duplicate the slide. Come on. Okay. All right, so we can get rid of these and these and these, these and these. Great. To swap these two elements, right? So 50 would come here, and 68 come here. 50 has been placed in its correct position. Now, do we need to place a correct element at position 6? Isn't the correct element already placed at its proper location, right? So this is already placed in its correct position. Moreover, if you a correct position. Moreover, if you have a look at the array, you will find that the array has been sorted. All right, the array is sorted. Okay. Now there are a few observations that we need to make first. All right. So what I'm going to do is I'm going to remove this entire thing and I'm going to delete the next slide. You can write observations here. Okay. Before we move on to the algorithm, first we need a few observations. All right. Observations. All right. So the first observation that we can make is this. If you notice very carefully, what are the values of I? So I starts from 0 and it ends at 5, isn't it? Because we don't need to figure out an element to place at the last index because the proper element has already been placed in the last index, right? So I was ranging from 0 to 5. All right. Now tell me, how can we arrive at 5 from size? How do you think? Size minus 2, right? So in general, I should write that, in general, I runs from 0 to size minus 2. All right, where size, you know what size is, where size is the length of the array. Moreover, if you notice, when the value of I was 0, the index range that we were searching was 0 through 6. When the value of I was 1, we were searching in the index range 1 to 6 for the smallest element. When the value of I was 2, we were searching for the smallest element in the index range 2 to 6. You notice a pattern? The lower bound of the range is always same as that of I, isn't it? And the upper bound always remains constant. And how can we arrive at the upper bound? 6. Size minus 1, because the value of size is 7. Let's write that observation. So when the value of I was 0, we were searching in the index range 0 to 6. When the value of I was 1, we were searching in the index range 1 to 6, and so on, right? So in general, we search for the smallest element while sorting in ascending order. Search for the smallest element in range. I just underline the above thing because this is important. In the range I to size minus 1. I hope these observations are clear to you. If not, then you will have difficulties understanding the algorithm that is on the next page. So I'm going over these observations once more. If you notice, in our algorithm where in our array, which is a size of 7, which has a size of 7, has 7 elements in it, the value of I goes from 0 through 5. So in general, if we have an array whose size is n or whose size is size, then I would go or run from 0 to size minus 2. Moreover, for every value of I, we were searching from I to size minus 1, because when I was 0, we were searching for the smallest element in the range 0 to 6. When I was 1, we were searching for the smallest element in the range 1 to 6. When I was 2, we were searching for the smallest element in the range 2 to 6. So in general, we search for the smallest element in the range I to size minus 1, right? So let's see the algorithm now. Alright, so ARR is our array that needs to be sorted, and size is the length of the array. Now, first what we do is we run a loop from 0 to size minus 2, because these are the locations where we must place the correct element. I must write it here, locations where we must place the correct element. Alright. Now, for each value of I, we find the index of the smallest element in the range I through size minus 1. We observed that, we wrote down the observation before, and we store it in a variable named, say, smallest index. Now, then we swap the element at in locations I with smallest index. Exactly what we were doing before. So let me come back to the table. So see, here we were swapping the elements at index positions 3 and 6. So that is what is written in step 2 of the algorithm. All right. So go over this video a couple of times, get these things cleared, and then you can move over to the next video where we write a program solution for selection sort. All right. So see you in the next one. Bye for now.